The other method is divisive approach, which is called as top-down approach. In this, initially all the nodes belongs to the same cluster. Okay. In this, what happens? All the nodes will belong to the same cluster. That means that first cluster. And then eventually each node forms its own cluster. So for example, what happens initially, all the data points will be forming one cluster, and then based on the similarity score, there will be some nodes which will be coming out from that cluster, and it will form their own cluster. But then if you notice, divisive approach is less widely used because the complexity would be more here. But in bottom-up approach, it is very simple because every point is represented as single cluster initially, and then they will merge based on the number of clusters and or based on their similarity score. So here, as you have seen in k-means clustering, we had final optimal k value. In hierarchical clustering, you can always change the value of number of clusters which you need, and then based on that you can cut the branch. And then, which I've already told, hierarchical clustering works especially well with a smaller data set, because for the higher data sets, the visualization would be quite complicated. Okay. So in this case, you have to predict the output by using all the supervised. So this is our final project, guys. Okay. Let's not go into this, but I'll just try to explain you what I'm trying to tell in my final project, which you guys have to work on it. So predict the output by using all the supervised machine learning algorithms and identify the differences in the result obtained using these algorithms. So the first project would be, which I've already told you last time, you can implement all the supervised learning at one shot by creating a user-defined function. Remember, guys? Yes or no? Right. So you can use that on the same data set which we will be providing to you, and then you can run that. But I would be happy if you work on second challenge or second project here, because that would be slightly complicated. What happens here, you will be having the data sets and you don't know which is your output here. There will be x1, x2 and x3 and so on. Okay, so there is no y, assuming that there is no y because it's an unsupervised learning. So first you have to perform clustering, and then you have to come up with your new feature, which is your clustering number, right? Remember cluster number 0, 1, 2, 3, what we have done yesterday in k-means. So that would be your output. Let's assume that would be your output feature, that the data point belongs to which cluster. So that is your output feature. And then try to understand the differences between these clusters. Okay. And then try to check that, try to split your data into 70-30 or 80-20 and use the predictive algorithm, that is supervised algorithm, and check whether your algorithm is also giving you the same cluster or not. Did you understand this, or shall I repeat it? I think I have to repeat this. So let's say you have some x1, x2 and so on, say xn. You have first record, say second record, and then say so up to 10,000 records. First, perform clustering analysis. Say you are working on vehicle data set, and then you will find the output, say, and you have found the optimal number of clusterings are 3. Say 1, 2, 1, 3, 1, 1, 2, so on. So these are the cluster numbers. Okay. Say these are the cluster numbers. Okay. Now let's say this is your output. Now we have used the unsupervised learning, you have found the output. Consider this as your output, and then you will understand the differences when you read the data. That all the data points cluster 1 has their own characteristics. All the data points with cluster 2 will have different characteristics. And all the data points which are going under third cluster will have different characteristics. So what you can do is, what I'm trying to tell is, once you are done with this clustering, unsupervised learning, split the data, say 80-20, then 8,000 would be in training data set and 2,000 would be in test data set. And then train your model on 8,000 and then consider y is your output, and then predict the output for this 2,000 data sets and check what is the accuracy which you are getting for predictive algorithm or classification algorithm, check what is the accuracy which you are achieving. So by this, what you are trying to do here is you are trying to define the outputs first by your own using unsupervised learning, and then you are also trying to predict your output, what you have got in unsupervised learning by supervised learning. I think it's very intensive what I've told just now, but yes, I've already repeated. Okay, now this is the thing what we have to do. And now if you notice, we have completed the concept for all the 10 weeks. Those 2 weeks will not be having any influence on your final project. But it's important to know those 2 topics also, because when we go into advanced machine learning, because if I'm not wrong, the second course, there will be another course which will be starting. In that, we'll be looking into complete mathematics of machine learning. Okay, so in that, and then the third course would be purely advanced machine learning, which will be deep learning. So for that, we would require those 2 weeks of agenda and the content. But for this course, the final project, it's in front of you, and this will not be influenced by your next weekend course. So the remaining 2 topics will not be influencing your final project. Okay, great. Now, before going into the Python coding, I want to ask a puzzle for today's session. The puzzle is very simple and very straightforward. It could be quite simple for you guys. I have a chessboard, and you know that chessboard would be of 8 by 8, right? Now, in this chessboard, what we need to understand here is, you know how does rook moves in chessboard? How does queen moves? How does horse moves? You know how does queen moves, right? Queen moves diagonally or straight. So I know that in real time, there will be only 2 queens on the board, one from the black side, one from the white sides. But what I'm try to understand my puzzle here. So there will be 8 by 8 chessboard. And now in this 8 by 8 chessboard, you have to place the queens as many as you can. Understand this. You have to place the queens as many as you can so that they are not killing each other. Did you understand this? That you have to place the queens as many as you can. For example, if there is one queen here and the second queen is here, the first and second queen can kill each other, right? Because queen moves in straight direction or diagonal direction. So you have to place you have to place as many queens as you can in this chessboard so that they do not kill each other. And you have to tell me what is the maximum number of queens that you can place. What is the maximum? If I don't tell maximum, you will tell that I can place 2 queens, 3 queens, but I want what is the maximum number of queens that can be placed on this 8 by 8 chessboard such that they are not killing each other. Okay, and then what is the strategy to place this maximum number of queens? So that please, as we have completed 10 weeks of course, which would influence your final project. So please start working on your challenges and complete the challenges, because then it would be helpful for us so that we can understand, are you able to understand the course or not in a better way or in a right way. Like first you are trying to understand the thing by yourself. For example, if you're stuck somewhere while working on your challenge, rather than asking for a support, you are directly looking for your own help by looking at all the different things, for example, textbooks, or if you have bought one, or for example, internet, you are trying to explore a lot of things. Then also you're not able to get the answer, then please contact us for the solution or for the support. But then what I'm trying to tell here, when you explore by yourself, you will understand a lot of things. You will understand a lot of other things as well. Okay. And once you complete this course, challenges, project, then you should be able to apply. You should start applying for the jobs as well. Okay. And that it's so, and if you are looking for a opportunity right away, then you should start working on this right away. Okay, great. Okay, so if you remember, this is a yesterday's data set, what we have done for k-means algorithm. And what we have done in k-means algorithm was we have imported the data using pandas, and then we have built a k-means algorithm, and then we have found the what data points will go under which cluster. Sorry, and then we have divided our cluster based on the numbering of the cluster, and then we have noticed that the visualization or the results were not good, but the reason was the scaling of the features. So because one of the features is having only 2 digits and others feature has around 5 or 6 digits, so your distance formula will be highly influenced by income. So what we have done was we have actually brought down both the features into a same scale using this user defined function which we have created, min max. Okay, and then again we have implemented k-means on that, on the new features, and then we have separated our data frames based on the cluster numbers, and then we have plotted that into a scatter plot, and then we have visualized that, and we have noticed that it was looking quite good. That means with very high efficiency. Okay, so now and then we have looked into elbow curve also in the k-means algorithm. Now in hierarchical clustering, same thing from scikit-learn or from SciPy. So you have to find the difference between this SciPy and sklearn. Okay, note down this. What is the difference between sklearn and SciPy? Okay, and tell me the answer in the next session. So from SciPy, what I'm doing, I'm importing clusters. From clusters, I'm importing hierarchy. And from hierarchy, I'm importing dendogram and linkages. Okay. Now, before going into this linkages thing, now you must be thinking, what is this linkages, right? So in hierarchical clustering, so linkages, there are 3 different linkages: simple, and then complete, and the last one is average. Okay, simple, complete, and average. So I'll tell you what happens with all the 3 linkages. So sorry, my bad, this is not simple. That's what I was not able to recollect. Yes, single, complete, and average. Okay, so single, what happens in singles, for example, you have formed a data points. Okay, and you have formed the first level of clustering. So what happens, and then you have to calculate the distances again and again, right? Because you will calculate the distance and then you will form the first level of clustering, and then you will calculate the distance again between the clusters. So now, for example, like the way we have done here, for example, this is one cluster and this is one cluster, right? And then we have to calculate the distance between this cluster and this cluster, right? So you must be noticing, how do we calculate the distance between this cluster and this cluster? So it's not a way that we calculate the distance from this point to all 3 points and this point to all 3 points. Initially, it will calculate the distances between the points, because every point is considered to be as a cluster in a bottom-up approach. But as we move up from bottom, as we are moving up, that means we are actually making some clusters, right? So once we form some clusters, then we have to calculate the distances and we have to keep on moving towards from bottom to up, right? So for that, there are three different ways of calculating this distance. How do we do that? What we do, we use single linkage. What does it mean? We calculate the distance between the nearest point of two clusters. Okay. And you know how to calculate the distance between these 2 points now, right? That is a single linkage. Okay. And then based on that, we form a next level of clustering. This is one single linkage. In complete linkage, what happens? Of course, then the distance should be minimum, right? Then only will form the cluster. The second way, or the second linkage, which is complete linkage, it's up to you which linkage you are choosing, okay? In second linkage, what happens? You will choose the farthest most points from these two clusters, and then you will calculate the distance. And based on this distance, again, there will be a lot of clusters, right? Again, there will be a lot of initially there will be a lot of clusters, right? So based on this farthest point distances, the one which has minimum will be combined to one cluster, right? If you notice this, always refer to dendrogram when you are confused. Okay, so that is complete linkage. In average linkage, what happens? If I'm not wrong, you can correct me, but it's been a while that I've used average linkage. You can correct me if I'm wrong. Like maybe you can also check what is average linkage at your side, and then you can tell me in the next session. But I've used single and complete linkage most of the times. So in average linkage, what happens? You will calculate the distance from all the points to all the points here, and then you will take the averages of the distances. Okay. Okay, what is its function? It's quite simple. For example, see, initially we are dealing with bottom-up approach, that you have to remember. Okay. Now all these points are single clusters, right? Now when you calculate the distance between the points, then you know that you can directly go and calculate Euclidean distance formula. Based on the distance, you know that these 2 points are very near and this will form a cluster. Now there would be a lot of points in the space, right? So for example, let's say that there are 3 points. Let's assume that there are only 3 points, 1, 2, and 3. Okay, let's take some other color here, not to confuse you. Let's say there are 3 points, 1, 2, let's say 3. Now we know 2 and 3 are very near to each other, so it will quickly form a cluster. By calculating the distances, these 2 will form a cluster. Now, as it is a bottom-up approach, what does it tell? Initially all the points will be its own cluster, and then slowly points will come and merge on it based on the similarity score. So now one also should calculate the distance from one to this cluster, right? See, between the points, it's easy to calculate the distance. But how will you calculate the distance between point, say point which is 1 and the cluster which is forming by 2 and 3? How do you calculate the distance? Will you calculate 1 and 2 and 1 and 3? But in the dendrogram, if you notice, the distance would be represented by only single value. This is the distance, right? This is the distance between this point and these 2 points. It's not the actual distance between this point and these 2 points. What it is trying to tell is, this is the distance, this distance is a distance between this point and to its corresponding cluster, because then there will be 2 distance values, right? So not to confuse that, the simplest way how to find a distance between a point and a cluster. So for that, there are 3 different linkages which people use. One is single linkage, complete linkage, and the third one is average linkage. Okay. In single linkage, what happens? the distance between 1 and this cluster will be calculated based on the nearest point. For example, 1 is near to 3, right? So this would be the distance which would be calculated and will be represented in the dendogram. So that is called as single linkage. In complete linkage, this, for example, let's say that there is one more cluster here with 4 and 5. So now one has to go with 2 and 3 or 4 or 5. That is important, right? So when we are using single linkage, one would calculate the distance from 3 and one would calculate the distance from 5. And then based on the minimum distance, it will get associated with that cluster, like the way it is shown here. That is a single linkage. But if it had to be a complete linkage, then what it does is it will calculate the distance from 1 to the farthest point, which is 2. And it will calculate the distance between point 1 and the farthest point in this cluster, which is 4. And then based on the minimum distance, this one will be associated with either this cluster or this cluster. Now, in average linkage, what it does, it will calculate the distance. One will calculate the distance between 2. The distance will be calculated between 1 and 2 and 1 and 3. And then the average value will be taken. Similarly, the distance will be calculated between 1 and 4 and 1 and 5. The average of those two distance will be taken. Now the one which is minimum between these two averages value, one will get associated with that cluster. So calculating the distances between points is pretty straightforward. Calculating the distances between clusters is a difficult thing. Because if you notice, at this point of time, if I cut my branch here, you would notice that these two would be a one cluster. This point would be a separate cluster, right? Now if I cut my branch at a top level, then will this point get associated with this cluster or with some other cluster, which is here? For that, it has to calculate the distance, right? And then how does it calculate? At the first level, it's pretty straightforward. All the points are considered as individual clusters and then it will calculate the distances among themselves. But at second level, it has to how will it calculate the distance? At the second level, in the sense when some of the data points already formed a cluster like this, then it has to calculate the distance based on this linkages. Okay, so it's good that Python has reminded me these linkages, and then otherwise I would have forgotten to explain this. Yeah, so same thing, import dendogram and linkages. Okay, and then you're putting all the points here X, and then you are using this linkage function and you're telling that implement single linkage. You can use complete or average, it's up to you. Okay, and then you can actually put the label list, whatever you want, like how many clusters you want based on that, and then you can try working on this. So I have not written this code completely for hierarchical clustering because I want you guys to work on it, and then you have to come back and tell me whether you are able to write a code or not. It will be very similar to k-means. It's just that you will be seeing dendogram with different linkages. That's it. In k-means, it was k value and elbow curve. Here it is dendogram and linkages. Okay. Now, so far so good. Before proceeding, I want to tell you one more thing, guys. Okay. Now, if you remember the sampling techniques in the first session which I've talked about, simple random sampling and stratified sampling, right? This would be an interview question. Okay. This has nothing to do with unsupervised learning. This has to do with supervised learning. I forgot to tell you this while teaching supervised learning. Say you have n features. Say you have 10 records. Ideally, you will not have 10 records. There will be a lot, but I'm just giving an example. And then it's a binary classification. You would notice that say you have 9 zeros, that means 9 records are going into data point or class 0, and the 10th record is going into the class 1. Then how would you solve this problem? How would you predict it? I think I've already given you example for this in k-fold, right? So this one cannot be there in test data set. You have to remember that. Ideally, this one cannot be there in test data set, right? So your simple random sampling, if you're using say 80 by 20, and then say randomly it has taken 8 records of 0 going into train, and then 2 records, one with 0 and one with 1 going into test. Then just imagine how will your algorithm predict the output 1 when you have not trained your model on this. Did you understand this? So this is very difficult to solve this kind of problems. If this a single record going into the test data set, okay, then it will be really difficult. But imagine that you have 2 classes or 2 records which goes into class 1, and then there are 8 records which goes into class 0, and now you're doing training, you're splitting your data training and test data set using 80 by 80 20%, and then assume that all this 8 records going into training and this going under test. Then how would you solve this? Then again it would be really difficult, right? So in this case, instead of using simple random sampling, you have to use stratified sampling, guys. So you have to use stratified sampling. What stratified sampling tells is you have to make sure when you're sampling, you get the right proportions of 0 and 1s. What does that mean? Say you want to split your data into test and train data set, and the proportions should be equal. The proportions of 0 and 1s in test, 0 and 1 in train should be same. What does that mean? Ideally, you should try for that. For example, if I'm doing 80-20%, then seven zeros and 1 should go here. 1 0 and 1 should go here. You're getting my point? What I'm trying to tell is you have to split this. You have to make sure that this 1 is going into both test and train. Yes, equal diversity, exactly. So this 1 is going into both test and train. Okay. So what in general people does it, for example, say you have 8 zeros and 2 1s, then ideally, okay, you're taking 80% into training, right? So 8 into 8, that means 6.4 zeros. Or let's not take this as an example. It will give you fractions. So let's do one thing. Let's say you have 100 records, 80 zeros and 20 ones. Okay. And then you want to split your data into 80 by 20 as train and test data set. Then we know that there should be 80 records in training and 20 records in test. But we have to make sure that the proportion should be same in training and test. So what do I mean by that? Then 80% of 80 would be 64 zeros, and 80% of 20 would be 16 ones. So ideally in your training data set, you should have 64 zeros and 16 ones. then how many zeros will be there in test data set? How many zeros and how many ones? Right, 16 zeros and 4 ones. That tells that what we are trying to do is, by stratified sampling, we are trying to make sure that the proportions of zeros and 1 in training data set should be same as test data set. So it was very difficult to explain that with the same example of 10 records. That's why I've chosen 100 records. So in test dataset, you will have 16 zeros and 4 ones. Finally, you will have only 20 records because you have splitted your dataset in 80 by 20. Okay. In Python, there is a separate syntax for this, for stratified sampling. You can look into that, but I wanted to explain this. So people will ask you in the interview what kind of sampling analysis which you will be using for splitting the data when you have imbalanced data set. No, there is a new term which is coming in, imbalanced data set. What does this imbalanced data set means?